So I picked up this Einstar little scanner by Shining 3D because I've seen some reviews on it by some other people, and everybody had good things to say. And for less than $1,000, I decided, hey, it's worth the risk, even if it's not that great. It's not that big of an investment compared to some other scanners that I'm used to using that are $60,000, $70,000, $100,000. So decided to give it a shot, and this is the first real test. The plan here is I'm going to scan this swing arm. Now, I've already scanned this swing arm with a high-end scanner in the past, and I've used that data to do a bunch of stuff. But I want to scan a part that I already have an existing scan of, and then I'll be able to compare the two and really just tell how accurate this is. Now, this isn't that big of a part. Volumetrically, it's, let's see, it's about 2 foot, so 60 centimeters by 11 inches, so 280 centimeters. Not that big. So keep in mind, the bigger the scan, the more room for error, the more inaccurate it can possibly be. But this is just kind of the typical size part that I scan, and I just want to compare the accuracy and just get a baseline for where I'm at. The scan quality looks good. It'll go down to a 0.2 millimeter resolution, so not super fine detail, but enough for most things. Now, the first thing you want to do when you scan is make sure the scanner's clean. Make sure all the cameras, lenses, everything nice and clean. You know, clean it with a lens cloth. That's your first step. Second step is calibrate it. Now, you don't have to calibrate it every time you use it. You could, but this is the calibration plate that comes with the scanner. Now, usually the scanners are matched to the plates from the factory. They know exactly the distance between each dot, and if the scanner gets dropped or there's a big temperature change, you always want to recalibrate it. This software is a little weird. The calibration procedure is fairly easy. It just gives you instructions and you follow them. But keep this calibration plate in good, clean condition. Don't bend it, don't beat it up. Keep it in this little baggie, and you should be good to go. I'm not going to show you how to do that. It's got instructions. It's super simple. Now this software, like I said, is a little weird. It seems more like the scanner is kind of designed for scanning people, for video games or whatever. I'm not into that. Everything I do is mechanical. So you do have a portrait mode, which is for a person, I guess. I haven't tried that. I leave it in object mode. And then you have a small object, which it says is smaller than 100 cubic centimeters. And then you have a medium and large object mode, which is bigger than 200 cubic centimeters. No, sorry, millimeters. So small is 100 by 100 by 100 to 200 millimeters. And then medium and large is larger than 200 millimeters cubed. So you got a couple different, I'm going to screen record this so you can see what's going on here. So these are your small objects, 100 to 200 millimeters cubed, and then medium and large, larger than 200. Pretty self-explanatory. You got features, texture alignment, hybrid alignment, markers. Those are the little dots that you can stick all over stuff. This came with some dots. I've used dots for a long time and I'm kind of sick of them, so I'm not going to use them. This part has enough geometry to not have to use them. And then you got your resolution. And your resolution, what this is doing, this is picking up points on the surface. Now, that resolution is how far apart those points are. You can think of it like pixels on a screen. Since this is an accuracy comparison, I want to see how accurate this scanner is. I'm going to do it on its finest setting, which is 0.2 of a millimeter. And then texture scan, which texture is kind of a funny, it's not the actual texture of the surface. That is the color of the surface. One of the cameras in this actually, I guess, takes photos, and it associates every single point in space with a color that it picks up from the camera. So this part has some scratches on it and all that stuff's going to show up. The color thing to me is kind of cool. I could take it or leave it. Yeah, doesn't really matter. It's neat that it does it. But like I said, I guess it's more geared towards portrait mode. So we're going to hit apply, and then it's going to give us some options for brightness. Now that brightness is the brightness of these LEDs right here. So you've got two cameras here surrounded by LEDs and then a third camera down here. Now if I hit the play button once, it's going to give me a preview. Those are going to light up and shine on the part, and it gives you this right here. It gives you this how red it is. It's kind of vague. Like I said, this software is kind of, it tells you some things but it doesn't really explain anything. So it says you want a little bit of red in there but not a lot. Now if you do a real shiny surface like this table, it's going to be a lot of red. The scanner is not good for shiny surfaces. You need to spray it with something that's going to give you an opaque or a matte finish. The swing arm will be fine. It's not shiny. It's anodized black. Part of it's cast, part of it's sheet metal. So the sheet metal part's a little shinier than the cast part, but this should pick it up just fine. Another thing, this won't do clear translucent surfaces, reflectors on stuff like motorcycles, blinkers, taillights. This isn't going to do it. But you can always, there's workarounds for everything. You could always spray that with something and get by with it. So that color looks good. So the next thing you do is just hit the play button and start scanning. Now with a scanner like this, any kind of handheld scanner really, it's a continuous scan. You can't scan this area and then move over here to scan this area unless you've already scanned the entire part. So say this car, if I wanted to scan here and then I wanted to scan over here, well, you would have to scan one continuous scan from one part to the other, or it's not going to know where it's at. You can't scan this area and then this area is separate, and they're not going to be lined up. There's no relation to it. Now you use a ferro arm or a hexagon or something like that, and an articulated arm with encoders, you could scan this little area and come over here and scan this area, and they're going to be in perfect alignment of just like they are on the car. Everything has pros and cons. This type of scanner, any handheld scanner, is not going to do that I know of. There are some that the scanner is mobile and there's a camera system up on a wall or tripod somewhere. Those you could do it, but we're talking cheap, not $150,000 scanning systems like that. So we'll get back to scanning this. There's your preview. It always pops up preview first, and then you hit the scan button. And you can see you want to make smooth movements, and you want to scan a good section of this part. You can kind of move around that area. Oh, see, moved too much. So it figured out where it was based off what I'd already scanned, but I tried to move it too far, too fast, and it doesn't like it. It throws up an error saying, hey, you messed up, go back. So we've just encountered an issue that I've had in the past and is very frustrating with this software. And let me turn on the screen record so I can show you exactly what happened. So right here, this area of the swing arm has it's a clamp. It's an eccentric clamp. It's a bore, and it's got these two bolt holes. Well, I had it scanned fairly well, and then the scanner for some reason decided, hey, I'm over here now, and it's added scan data where it doesn't belong. Now, maybe I'm doing this wrong, and I don't know, but the instruction book on this software is like 3 pages, and it's basically like how to turn it on, how to get it plugged in, and there you go, that's it. It's very vague. But now that I've added this, some other softwares, there's like an undo button, like undo your last scan. That's exactly what it needs here, because I've got this, and I don't know if there's any way to get rid of this without just deleting your entire scan and starting over. Now, I could probably I could probably get around this issue and not have it had I put dots on the part, but I don't want to put dots on the part. It has good enough geometry where I shouldn't have to. So this option here, delete your scan, optimize point clouds, or preview, those are the only things I have right now. So I can't just go in and undo what I just did. And that's extremely frustrating because I'm going to have to start over now and rescan this entire part. And this has happened a few times on other parts that I expected it on, like wheels. You know, it's round, the spokes are repetitive, it doesn't know exactly where it is. So when I scan wheels, I put things around the wheels that it can see at the same time and say, hey, okay, I see that part, I know where I'm at now. I don't think this feature is repetitive enough for it to do this. Now, had I scanned around this other side here more, before I went to the back, that probably would have solved that issue, but I didn't see that coming. So I guess I'm just going to have to start over now, which isn't a huge deal. I'm only a few minutes into the scan, but it just sucks to have to do that. And I think they could easily add an undo last scan button and solve this issue. But as far as I know, that doesn't exist. So please correct me if I'm wrong. Oh well, start over. Another neat thing that I like about this software is there's this little toggle switch here you can turn on that tells you data quality indicator. And it basically just says out of their scan data that you've already captured, oh, it won't let me do it while I'm scanning, so let me pause it. It says out of the data that you've already captured, what is the quality of it? So green is obviously good, red is obviously usable, I guess, but not ideal. So I'll leave that on now so you can see what it's showing me while I scan. We'll find an area that's got some red and we'll go over it a few times from a few different angles and see how it changes from red to green. You see on the left side of the screen there, that's your focal length rangefinder, I guess. Too close, gets red. Too far, it turns blue. You got the same light on the scanner itself, but I find you're never really looking at the scanner while you're scanning. You're usually looking at the screen. But it's nice that they put it on both, just to have. All right, now for the fun part, the moment of truth. This is the scan data I took a long time ago with the high-end scanner, and the easy way to tell that is it's complete. The scan I just took that you watched me take, I don't have some of the bottom. So first thing I did is I brought it into this software and I created a surface from this mesh. Now a mesh and a point cloud aren't that different. A mesh is just combining 3 points into a triangle. So you can see this has a very fine resolution. There's a lot of detail here. We can look at some numbers cast in it or some stuff that's been etched in it. And it hasn't been decimated at all. So let's look at some details on this. It's 1.345 million points, 2.6 million triangles. So it's a pretty data heavy scan, we'll say. Now I've surfaced this part, and in the parameters for surfacing it, I told it that I'm only going to allow it 1/1000th of an inch deviation from the actual mesh. Now this is not a watertight scan. I did no post-processing or editing to close in all these holes. This is just as scanned. So it took about an hour to create this mesh because, or sorry, not the mesh, an hour to create the surface body because I gave it such a tight tolerance to hold. I didn't want it to deviate at all. So I can turn that on now and you can see it kind of shine through its silver. We'll turn this off and you can see it better. So there's our surface body. Now the next thing we want to do is, just so we can trust it, is compare the surface to our mesh. We can do that up here with this little button. And it usually takes a few minutes because it's computing a lot. Well, that was fairly quick. So right here's my scale, and I can change that. So right now, anything within plus or minus 4 thousandths of an inch is green. So I'm gonna move that down to 1 thousandth of an inch. Nope, it's half a thou. Thing's a little tricky to move. There it goes, +1, and then we'll go -1. All right, so we can see the vast majority of the part is green. There's a couple little spots, but little polka dotted spots don't really matter. We're looking for big areas that are colorful. So we know now that our surface is extremely accurate to the original scan. So now what we're going to do is suppress our original scan, which is this pink one. I'm going to go up here. That's what I've imported last. Suppress that one. And then we're going to pull up our scan that we just took with the Einstar. Now the entire reason that I've turned this model, or I'm sorry, I've surfaced this mesh is because this is a reverse engineering software. This is not an inspection software. So I cannot do a color comparison on a mesh to another mesh. It has to be a mesh to a surface or a solid body. So that's why I surface that so I can compare my new scan to the old scan, even though it's not really the old scan, it is. So the first thing we do is we can look at it and we can see, okay, I've done a best fit alignment, which ideally I would have done a datum alignment to this pivot here. So you line up the axis of this pivot perfectly, and then everything from there will be farther off than this area would be. But I don't have good enough scan data on that to do it, so I've just done a best fit, which is just another type of alignment. It just looks at every point over the entire part and finds the minimum deviation between them all as it's moving one part in relation to the other. So now that we've got our new scan from our new scanner and the surface, I'm going to go ahead and ask it to do a comparison, an accuracy analyze, which again usually takes a little while. Another thing to note, when I originally scanned this, I scanned it inside the house at 69 degrees, which is usually like the standard for metrology. As we all know, parts expand and contract in different temperatures. Now, when I just scanned this one in my garage, it was cooler out. It was in the mid 50s. So we'll say 10 to 15 degrees colder. Now, this part being aluminum, it is going to contract slightly. I don't know the exact math on it. I could do the formula and figure out exactly how much shorter the part should be given its length, but I haven't done that yet. I'm assuming it's just a few thousandths of an inch, but I may actually do that here in a minute just for the fun of it. All right, now we've got this comparison up. You can see I've got my scale over here back at 1 thousandths of an inch, plus or minus, will be in the green zone. And then anything above that is going to be yellow and then red. Anything below that is going to be blue. So the thing to remember is our surface here is the original scan with the high-end scanner. So we're going to assume that that's more accurate. And then we're comparing it to the mesh from the new scanner. So anything that is blue is saying it is smaller than the actual part, but the parts are original scan, so that means that our new scan is actually larger than the original part or larger than the original scan. So we can hold our cursor wherever we want. We'll hold it on a green area and it'll say 0, 1,007 inch. You move over here to blue and I'm seeing 4 thousandths negative, which is actually positive if you think of it that way. And then our yellow areas here are the opposite. So that's 2,007 inch. So I see 4, 5, 6. So I see 6 in spots, but most of it's around 3 and 4 thou. One direction. And then the other way, I see 2, 3, it jumps to 4 every now and then. So if we add up our total of -5 and +4, we're around 9 thou total deviation from the other scan. And remember, this is just comparing one scanner to another. Like I said, the temperature difference it's not negligible, but it's a few thou. If I were to do this over, I would definitely do both scans same day, same place, just to minimize any variables, because when we're talking about 3, 4, 5 thousandths of an inch, we're splitting hairs. It depends on what you're doing. This scanner may be good enough to do something like a transmission adapter plate. If you're trying to put a different transmission on an engine and you scan the back of the engine, you scan the transmission, you design an adapter, you really are talking, you need to be within a thou or two on every dimension for it to fit and for everything to line up correctly with the input shaft. So I'm not going to say the scanner is good enough to do that. You're probably going to want to do it with a higher end scanner or some other methods. But looking at this color map, we're really not that far off. So let's change this to, we're going to go to 3 thou, which is about the thickness of a piece of paper. So everything you see in green here now is basically within one paper thickness off from a $70,000, $80,000 scanner to a sub $1,000 scanner. Now, I don't know about you, but that's pretty impressive to me. I'm quite happy with the cost of this scanner and the results I'm getting. So obviously it's not perfect. It's really good though for the price. I mean, I probably wouldn't design a lot of really close tolerance machine parts based off scans with this scanner. At least if you do, double check. But for a mechanical mindset, the scanner's not that bad for the price. Now, I'm comparing a $70,000 to $80,000 scanner to a sub $1,000 scanner here, and that's a pretty close between the two. It's closer than I honestly would have thought it was going to be. It's pretty impressive. Now, the software does leave a little bit to be desired, but the hardware itself is not that bad. And you can see I don't have scan data in this area because we didn't scan the bottom. So you can see that I am comparing the scan data from the Einstar, but that's not a bad result. So I guess the main takeaway here is the scanner is pretty damn accurate. You got to remember we're comparing a cheap sub $1,000 hobbyist scanner to a $70,000 high-end scanner. Now that high-end scanner is a Creaform Handyscan Black Elite, which is very accurate, but $70,000. So that's why I wanted to do this comparison. Now this is the base model or cheapest model that Shining 3D offers. They do offer a lot of high-end scanners too, but I have absolutely no experience with those. So all in all, I am very happy with my purchase of this scanner. It has exceeded my expectations. Software has some little bugs and some things I think could be improved upon, but overall as a package, I think it's a great investment if you're going to use it and know its capabilities, and you're not looking for extreme precision, because you really do get what you pay for in this scenario. But I think for 1/70th the cost, it's not 1/70th the product. So take this with a grain of salt and use it however you feel fit. But this is my first. Right now it's my only, but I may do some more comparisons later on with ferro scanning and this scanner at the same day and the same time, just to take out some variables. But I hope you enjoyed this video, and feel free to like and subscribe if you want. Thanks again.